Hello everyone, this is my introductory video for the GSoC project Improve BeagleV Ahead support. Before we dive into it, a little bit about me. I am an upcoming Masters in Embedded student at KTH Royal Sweden. I am an active contributor in the RISC-V architecture and have contributed to the upstream projects. I have a deep interest in embedded Linux devices which are specifically running RISC-V architecture, and I am also maintaining LeChPy 4a in build root. LeChPy 4a is a similar board which is similar to BeagleV Ahead. A little bit of project overview. So the aim of this project is to modernize the BeagleV Ahead's software support, which includes the kernel, Yocto documentation and other peripheral support. This is important because in the current state of this board, it is deprecated and the Yocto layers are given by the vendor are outdated and no longer available, and there is a lot of upstream alignment issues and proper documentation is not there for this support. So this project tries to fix those issues so that more and more developers can get access to this board and develop with it. The key objectives are to first understand and fix the Yocto meta RISC-V support for BeagleV Ahead. Then we'll create a pipeline for daily Yocto builds, and then I will try fixing the Wi-Fi support. Then we'll be implementing the microbus support for this board, and then some documentation needs to be improved. A few areas are still unclear. We'll try to fix those, and then we'll add a few demos about on using this board. And before we dive deep, a little bit of RISC-V architecture. So RISC-V is a free and open source instruction set architecture, and RISC stands for reduced instruction set architecture. It is somewhat similar to ARM, but RISC is open source in nature as compared to the closed source nature of ARM. And RISC-V is a set of ISA where each ISA is called an extension. It supports 32-bit, 64-bit and 128-bit mode, and there are 32 general purpose registers and 3 privilege modes: machine, supervisor and user mode, and it has control and status registers for each privilege mode. A little bit about our board. So BeagleV Ahead is based on the Alibaba T-Head TH1520 quad core SoC. It is using the Xuantai C910 cores and C906 for the audio DSP. It has 5 gigaflops of imagination GPU and 4 TOPS of NPU. Although I haven't tested the AI capabilities yet, but they are still a work in progress in the upstream kernel, whereas the vendor libraries support YOLO version 5. And it has 4 GB of low power RAM and 16 gigs of eMMC storage. Along with that, it contains a microbus shuttle expansion, then JTAG for some debugging, Ethernet for network connectivity. Along with that, it has Wi-Fi support, Wi-Fi and Bluetooth. So the current status is I have gathered all the hardware and required tools. Then I am able to successfully build the upstream meta RISC-V Yocto image, and I have studied the microbus peripheral and written a basic Wi-Fi patch. Although the current patch doesn't work because SDIO is blocked by the eMMC driver. It's a blocker and we have to dig deep into it. The expected outcomes of this project will be BeagleV Ahead will be in a better shape for developers, then up-to-date images with modern kernel and peripheral support, and there will be a rich documentation and a few real-world application demos. Then along with that, a robust CI pipeline which will build daily Yocto as well as the Debian images. Then Debian image pipeline is currently working properly. Then long-term impact will be to revive this board and sustain RISC-V development with Beagle board. Thanks for watching.